Okay, so thank you, Mr. Chairman. This kind of presentation is related to a very interesting topic that is very trendy in this moment because it's a sort of contamination of the electronics and civil engineering field. So in the same time, we are discussing about electronic stuff and also about civil engineering. This is this kind of subject, we can say subject or topics as you like, goes under the name of IoT. IoT means Internet of Things, and this is considered very very interesting from several fields of the technique. We can start always from the earthquake. They are in our mind in Italy, in Albania, in all our Mediterranean area. We are suffering these things, and so we are going to face the problem related with the earthquake. So the last year I was in Albania, and I have a chance also to visit the place like Durazzo, like Tirana, thanks to my friend from Polish University. And then I had to see what happened there. And then what is terrible that we cannot imagine often what is the situation of the buildings. And sometimes what happened to our our category, our structural engineer, often we are called to go on site and do such kind of aftershock work and try to imagine just from a view, from a surveying from outside, just looking from outside, what is the situation of the building. And usually we are like a sort of a little fairy tale, or we can say we need to have a sort of magic stick to understand what is inside of the building. So this is very difficult. And I several times, since several years I do this, I feel very frustrated sometimes because I cannot do very deep information. We cannot get more deep information. Let's look for a moment in the situation where we have we are in Venice. We have this kind of a sudden collapse of the bell tower. It was at the beginning of the last century. And my idea is that I would like to have, now that we have a lot of technology, I would like to have there a sort of sensors that could give me some information about what happened there. So if I can put there a sort of a little my ear can be there, probably I can feel more confident, and I can also give more safety to the structure. My dream is to have a sort of comprehensive knowledge about the structure, and then I want to see what is the situation of the frame, of the beam, of the beams, of the columns, everything. Why I cannot get acceleration, stress, strain, temperature, humidity, even the condition of the corrosion of the bar. This is very important. We know that how important is the situation. So what we are going to see is that after a while, we can now use this kind of technology. It's called IoT, but it's based on electronics. The electronics now became so cheap, and also perform a permanent monitoring. We can see that we can have very little element, very little sensors that are cheap and affordable, and also not so disturbing the structure. So we can use also embedded sensors. This is very important. That's why we say Internet of Things. We know that people are accustomed to see Alexa. Alexa is a sort of domotic king of the house. They can manage the temperature of the house, the lights, can turn on the the TV, probably the washing machine or everything else. But my idea is I want to get this inside of a structure. So I want to make this more smart building with such kind of technology. For instance, I want to put inside of a bar something that can tell me every single second, can record what is the situation of the bar in the frame. And just with some little component that can be easily related to the Arduino platform. I just remind you that Arduino is an Italian project from Ivrea. And then what we did, we are doing something that can be pretty interesting. We are going to make retire this big box that costs thousand of euro, and then we are going to build very little things inside of this platform that can control the stress, the strain of the test we are doing. And but I will not tell you that the results of my test when I compare these two devices, one very costly, very expensive, the other one very cheap. One is very heavy, about 20 kilos. The other one is just less than 100 grams. I will not tell you that when I make the comparison, the results is that we have a very little difference, and then the percentage, 5 or 6%, is very limited compared with our needs. Also, I will not tell you that if I use this kind of dynamic situation, even with dynamic, with the strain gauge, I can recover pretty good solution compared with comparable with the normal accelerometer, very much costly. So my idea is to have inside of my house a sort of box in the basement where I can check time on time what is the situation. And then I can get the light, the red light or the green light to know where is the problem for that kind of situation. This kind of research is related to this kind of, we can say we are exceeding our field of civil engineering. We are trying to, this is not invasion of another field, means electronics. We're just using some tools. But it's important to know these tools and to know how to manage. So we want to use this one because it's very cheap and expensive. And also it's important we can make a remote control, and then we make very permanent. Permanent means all the life. It means the idea is to when building starts, when the building born, you should have this kind of little system with him, just like we have with the car. So the car is a sort of a situation that give you control. You have control over everything, even under your when you sit, you have your sensors that then suggest you to put on or off your safety belt. So we say that this is an idea. We want to have a building like a car. So one smart building means more safe building. I will say thank you to everyone, and then I want to tell you this is a very big group that we are studying these kind of things. And I will also invite you to everyone to join us for next research. Thank you very much.
Thank you very much, Professor. Is there any question or comment?